Welcome to lecture series of Mathematics 1. This is Hitesh Manglani, Assistant Professor at LG Institute of Engineering and Technology. Today we will discuss three indeterminate forms. So first one is 1 raised to infinite, then second one is infinity raised to 0, and third one is 0 raised to 0. Now let us discuss examples related to these forms. So first example, evaluate limit x tends to pi by 2 sin x whole raised to 10x. Okay, so here first of all we will have to check the form of this question by putting value of x, that is pi by 2. So here if we put x equal to pi by 2, so it will be sin pi by 2, and value of sin pi by 2 is 1, and 10 pi by 2 is infinite. So this is 1 raised to infinite form. Okay, so how to solve these type of forms? So for that, suppose y is equal to limit x tends to pi by 2 sin x whole raised to 10x. Okay, so now we will take logarithm both sides. So here taking log both sides, so it will be log y is equal to limit x tends to pi by 2. So if we take log, then 10x will be here, then 10x log sin x. Because if we are taking logarithm, then whatever in the power, then it will come over here. Okay, so log y is equal to limit x tends to pi by 2, 10x log sin x. Now we will have to check the form of this by putting x equal to pi by 2. So value of 10 pi by 2 is infinite, and here sin pi by 2, that is 1, and value of log 1 is 0. So now it is infinite into 0 form. So how to solve infinite into 0 form? So for that, here we will write down limit x tends to pi by 2. Okay, so here this can be written as log sin x divided by cot x, because 10x can be written as 1 divided by cot x. So now this will become log sin pi by 2, and sin pi by 2, that is 1, and value of log 1 is 0. Okay, and cot pi by 2 is 0. So now it will become 0 by 0 form. So now we can use L'Hopital rule. Here applying L'Hopital rule, taking derivative of numerator. So if we take derivative of log sin x, okay, here limit x tends to pi by 2, then derivative of log sin x, that is 1 divided by sin x, because derivative of log x is 1 divided by x. Then we will have to take derivative of bracket. So derivative of sin x is cos x, so into cos x whole divided by derivative of denominator, that is cot x. So derivative of cot x is minus cos x square x. Now if we simplify this, then it will be limit x tends to pi by 2 cos x divided by sin x, and 1 divided by cos x square x can be written as sin square x, because sin x and cos x are reciprocal of each other. So here it will be minus sin square x, because here it is minus. Okay, so if we simplify this, then limit x tends to pi by 2 minus sin x into cos x, because sin square x divided by sin x will be minus sin x. Okay, now replacing x by pi by 2, so here it will be minus sin pi by 2 into cos pi by 2, and we know that the value of cos pi by 2 is 0, and value of sin pi by 2 is 1. So 0 into 1 will be 0. Therefore log y is equal to 0. So here log y equal to 0, but we have to find this limit. We will have to find the value of y. So y will be e raised to 0, because log y is 0, then y will be e raised to 0, and e raised to 0 is 1. So value of y is 1. Therefore answer of this question is 1. So this way 1 raised to infinite form can be solved. Now let us discuss second example related to this topic, that is evaluate limit x tends to 0 1 divided by x whole raised to 10x. So here first of all we will have to check the form of this question. So for that, replacing x by 0. So here 1 divided by 0 will be infinite. Okay. So infinite, and value of 10 0 is 0. So it is infinite raised to 0 form. Okay. So first of all we will suppose y is equal to limit x tends to 0 1 divided by x whole raised to 10x. Okay. Now to solve this type of forms, we will have to take logarithm both sides. So taking log both sides, so here it will be log y is equal to limit x tends to 0, then it will be 10x into log 1 divided by x. Because if we are taking logarithm, then 10x will be here. Okay. Now if we simplify this, then it will be limit x tends to 0, 10x, and log a by b, that is log a minus log b. So this will be log 1 minus log x, and value of log 1 is 0. So this can be written as limit x tends to 0, 10x into minus log x. Okay. Now we will check form of this. So for that, replacing x by 0. So value of 10 0 is 0, and value of log 0, that is minus infinite, but here it is minus, so it will be plus. So this will be 0 into infinite form. Okay. Now how to solve 0 into infinite form? So for that, this can be written as limit x tends to 0 minus log x divided by cot x, because 10x can be written as 1 divided by cot x. Okay. So now if we replace x by 0, then here it will be value of log 0, that is minus infinite, and here it is minus, so it will be plus infinite, and cot 0, that is infinite. So now it is infinite by infinite form, so we can use L'Hopital rule. So by L'Hopital rule, taking derivative of numerator, so derivative of log x will be 1 by x, so here minus 1 divided by x, and then derivative of x is 1, so no need to write down. Then taking derivative of denominator, so here in the denominator there is cot x, so derivative of cot x is minus cos x square x. So if we simplify this, then it can be written as limit x tends to 0. 1 divided by cos x square x will be sin square x, and minus minus cancel out, so it will be sin square x divided by x. Now if we replace x by 0, so here it will be value of sin 0 will be 0, and in the denominator it will be 0. So it is 0 by 0 form. So again we will use L'Hopital rule. So for that, taking derivative of numerator, that is sin square x. So derivative of sin square x will be 2 sin x. Okay. Then we will have to take the derivative of function, that is sin x. So derivative of sin x will be cos x. Then divided by derivative of x. So derivative of x is 1. Now as you can see, here we have obtained non-zero value. So we will replace x by 0. So here it will be 2 into sin 0 into cos 0 divided by 1, and we know that sin 0 is 0, so this will be 0. So we have obtained value of log y equal to 0, but we will have to find the value of y. Okay, so y will be e raised to 0, and value of e raised to 0 is 1. So answer of this question is 1. So this way infinitive raised to 0 form can be solved. Now let us discuss third example related to this topic, that is evaluate limit x tends to pi by 2 cos x whole raised to pi by 2 minus x. So here first of all we will check the form of this question. So for that, replacing x by pi by 2. So if we replace x by pi by 2, then value of cos pi by 2 is 0. And here if we replace x by pi by 2, then pi by 2 minus pi by 2 is also 0. So it is 0 raised to 0 form. So how to solve 0 raised to 0 form? So for that we will suppose y is equal to limit x tends to pi by 2 cos x whole raised to pi by 2 minus x. Now taking logarithm both sides. So here we will take logarithm both sides. So it will be log y is equal to limit x tends to pi by 2. Then this power will come over here, pi by 2 minus x log of cos x. Okay. Now we will check form of this. So if we replace x by pi by 2, then here pi by 2 minus pi by 2 will be 0. And cos pi by 2, that is also 0, and log 0, that is infinite. So this will be 0 into infinite form. Okay. Now how to solve 0 into infinite form? So we will write down this as limit x tends to pi by 2 log cos x will be in the numerator divided by pi by 2 minus x whole raised to minus 1. Okay, because here pi by 2 minus x can be written as divided by pi by 2 minus x whole raised to minus 1, because if we simplify this result, then it will be same. Okay, so now if we check form of this, then here it will be infinite log cos pi by 2, that is infinite, and it will be divided by infinite. Okay, so it is infinite by infinite form. Now we can use L'Hopital rule. So using L'Hopital rule, limit x tends to pi by 2. So for that, taking derivative of numerator, that is log cos x. So derivative of log x is 1 divided by x. So it will be 1 divided by cos x. Then derivative of bracket, that is cos x. So derivative of cos x is minus sin x. Okay, whole divided by, then here we will have to take derivative of pi by 2 minus x whole raised to minus 1. So for that we will use the formula, that is derivative of x raised to n is n into x raised to n minus 1. So here it will be minus 1 into pi by 2 minus x whole raised to minus 2. Okay, then we will take derivative of bracket. So here pi by 2 is a constant value, so derivative of pi by 2 is 0, and here derivative of x is 1. So here into 0 minus 1, so it will be minus 1. Now if we simplify this, then it will be limit x tends to pi by 2, here minus, and here minus and minus, this will be plus, but because of this final answer will be in the minus. So this will be minus sin x divided by cos x. So it can be written as minus 10x, and here it will be pi by 2 minus x whole square. Now here if we replace x by pi by 2, then value of 10 pi by 2 is infinite, and here pi by 2 minus pi by 2 will be 0. So this will be 0 into infinite form. So how to solve 0 into infinite form? So for that we will write this as limit x tends to pi by 2 minus x whole square divided by cot x, because 10x can be written as 1 divided by cot x. So now it will become 0 by 0 form. If we replace x by pi by 2, then pi by 2 minus pi by 2 is 0, and value of cot pi by 2 is also 0. So now we can use L'Hopital rule. So by L'Hopital rule, taking derivative of numerator, that is pi by 2 minus x whole square. So if we take derivative of this by using the formula, derivative of x raised to n is n into x raised to n minus 1. So here it will be 2 into pi by 2 minus x whole raised to 1. Then we will have to take derivative of bracket. So here pi by 2 is a constant value, so derivative of pi by 2 will be 0. And derivative of x will be 1. So here we will write down 0 minus 1, that is minus 1, whole divided by derivative of cot x. Now derivative of cot x is minus cos x square x. Okay. Now if we simplify this result, then it will be here minus will cancel out. So here it will be minus limit x tends to pi by 2. Then here 2 into pi by 2 minus x, and 1 divided by cos x square x can be written as sin square x. Okay. Now if we replace x by pi by 2, then pi by 2 minus pi by 2 will be 0, and sin pi by 2, value of sin pi by 2 is 1. So 0 into 1 will be 0. So we will get answer 0, that is value of log pi is 0. Okay. So log pi is 0, but we will have to find the value of y. So y will be e raised to 0, and e raised to 0 is 1. Therefore answer of question is 1. So in this way 0 raised to 0 form can be solved. So in this lecture we have discussed 3 indeterminate forms, that is 1 raised to infinite, infinite raised to 0, and 0 raised to 0. Thanks for watching this video. I will see you in the next lecture.